So in this video, I will be explaining and showing how to solve an equation using MATLAB. So the way that we start this off is we're going to type the functions clear in CLC to make sure that everything is cleared. All variables are cleared out from the workspace, and CLC clears out the command window. And we'll do that every time we run this code so that everything starts fresh. The next thing that we'll do is we'll establish our system variables. So we use the sims command, and in this case we'll be using the variables a, b, c, and d. And the equation, which is shown right here, the equation is established by using the letters EQN to equal this equation: a cubed plus b plus c plus d equals m. And you have to use a double equal sign to make sure that your equation actually equals a value, otherwise your code might return an error. So in this case, we're solving our equation for d, since a, b, and c have already been pre-established. The first example, a will just be a single number, but for two future examples, a will be a vector of numbers, and then m, the number that the equation is equal to, will also be a vector. So to start off, we've already written our equation using EQN and writing out the equation. Secondly, we will set another variable, in this case s of d, so solving for d. And then we will use the solve command to solve the equation. So you type in solve and then the variable that represents your equation, in our case EQN, and then the variable that you are solving for, d. So if we run that, you get a value of -6 because a is a single value, and so is b, c, d, and then equals a single value, so you get -6 as your answer. Now, if we change this a little bit, instead of making a single value, and we now make it a vector of values, that means that when you solve for d, d is now going to also equal 5 different values because you're testing the equation out 5 different times for 5 values of a. So the way that we do this is we now have to set up a for loop. So to set up a for loop, you have to set the number of times that you will iterate the for loop. So in our example, we have a being a vector of length 5 because it has 5 terms. So you set the iteration variable n equal to the length of the vector a. So n will be a value of 5. So now, comment this out so we don't run the incorrect value. So for the for loop, you set your number of iterations, so 1 to n, 1 to the length of your vector a, and then now your equation has to run 5 times through the for loop. So equation of 1, equation of 2, 3, and so on. So that's set up to represent that, to show the different values of a that the equation will have. And notice that I put the period before the caret symbol, raising it to a certain power, because a is a vector, so if you want to raise each individual value within this vector to a power, you have to put a period before the caret symbol, otherwise it will not work correctly. So what this for loop represents is that this equation will be solved for each single value of a. So we go ahead and run this code. And now notice here how if I hover over s of d, it says the variable sd appears to change every size on every loop iteration. And MATLAB recommends that I pre-allocate this for speed. So the way I can do this is I can say that s of d, I can pre-allocate it by saying that it is zeros of 1 to n. And remember, n is the length of the vector a. So I'm basically establishing an empty vector of zeros for s of d before I run it. And then the same thing with the equation here. The equation is written down, already pre-allocated. This will also speed up the code and prevent any possible bugs. So we run it again. And now it does run just slightly faster and the same result. So now what if a was a vector and m, the value that the equation is equal to, is also a vector. Well, that's the same thing, except the only difference here in the for loop is that we now have to set m equal to m of I to make sure that m gets iterated with every single run through of the for loop. So for the example of the first iteration, equation of 1 will be the first term of a of 1 raised to the third power, plus b plus c plus d, equaling m of I, so m of 1, the first value of this vector m, and then so on for the second values, third values, and so on. And then this SD of I will also, as previously, return a vector of 5 values. And of course, we're solving for D still. And so now that's your second value of S of D. So I hope this makes sense, and I hope you learned something from this. Thank you for watching.